everyone. In this presentation, I'll walk you through a simple but powerful machine learning application using YOLO V8. It's like a real-time object detection model developed by Ultralytics. So what is YOLO V8? So YOLO stands for you only look once. So which means the model looks at the image one time and detects all objects at once. So making it extremely fast. So when we put the image of aeroplane or car or anything means like it will detect by itself by just scanning the picture, and then it will detect whether it is a car. It will notify it is a car, it's a aeroplane, like that. So YOLO V8, so V8 is the version 8. So is the latest version of this model. So it comes with improvements in accuracy, speed, and user experience, and it's trained on the coco dataset, so which includes 80 object categories like person, car, airplane, dog, and more. So it can be used in many things like in the autonomous vehicle. It can detect the pedestrians, like we can see in the latest Tesla model car. Like we can detect the pedestrians like next to our car and vehicles and signs also we can able to do. And it's mainly used in the surveillance industry. Like it can be integrated into the web cameras and it can detect the weapons, guns, and everything. And also in the retail industry also, most of the people are using that for product monitoring and customer tracking. So who are trying to steal the object, or it can also used in the supermarkets and everything, and in the healthcare industry also it's used for medical image analysis. So the key features of YOLO VB. So when compared to the all the other versions of YOLO, so the version 8 is the latest version. So it's having more accuracy and the speed is very fast. You can't even imagine. And it has a pre-trained on Coco dataset. So it has 80 different things are there. So whenever we put most of the things are inside into that 80 classes. So it's almost detect almost everything. And it's like a simple Python API using Ultralytics library. We can just install the Ultralytics library and we can use the YOLO VB. So the installation. So to get started, we need to install the Ultralytics Python package. So in the notebook or anything, like we can just install the pip install Ultralytics, and then that's it. Like it installs everything you need. The model dependencies like OpenCV and PyTorch and all pre-trained weights, everything will be installed. And then these PyTorch and OpenCV also very useful and for loading the model. So now let's load the model. Like from Ultralytics import YOLO and model equal to YOLO v8n.pt. So the YOLO v8n.pt refers to the nano version. So it's the fastest and smallest model. So you can also try YOLO v8s and the YOLO v8m or YOLO v8x for larger ones. So these models are already trained, so you don't need to do any training yourself. So for running the detection. So next let's pause in our image to see what YOLO detects. So we can see like the image.jpg, that's our input image. For example, we are showing this. So this loads the image and runs the object detector. So YOLO automatically draws boxes on the images window showing which object it found and how confident it is. So in my image, it detected one airplane with a 90% coincidence and one car with 61% coincidence. So let me show my code. So this is my code. Oh, sorry. So here it is. I just installed the pip install Ultralytics. So the requirements already satisfied. And then I'm just loading the pre-trained YOLO model. That is the V8. And just from Ultralytics import YOLO. And then the YOLO image is my image that I gave as an input. So it's already detected like this, one car, one airplane. It got detected in 256 of 9 milliseconds. The speed is 17.6 milliseconds. As I said, it's having its accuracy and speed is very fast. and all the timing details are here, the pre-process and post-process per image, and the shape also defined here. So these names like print out name, so these are all the 80 classes. It's already trained in the Coco dataset. So zero for person, one for bicycle, like two for car, like it is. Like we can see a lot of things are here, like knife, fork, carrot, everything are here. So and then like so we can see that four for aeroplane, right? So in my code, I put like if the class is equal to 4, then it will detect, then it will print the aeroplane detector. So this is the thing. And confidence also will be noted here on the box. So then I imported the CV2 for computer vision to detect the image and to put as a box everything. So I again put the YOLO.jpg, and then for drawing the rectangle boxes, so I just put cb2.rectangle and converting the image from BGR to like red, green, blue, like RGB images. And then this is the thing. This is the final output we can able to find. So it will cover the whole thing. You can see the edges also. It covers the whole thing, the aeroplane, and then the car. Then the aeroplane is notified here, and the car is notified here. So this is how it will work. So this loads the image and runs the object detector. YOLO automatically draws boxes on the image window and showing which objects it found and how confident it is. So as we can see from the code, like the confidence is 89%. So this is 89% confident that it detected the image, detected the thing that located in the image. And then for the visualization, so we can use like show or OpenCV plus Matplotlib. So for drawing bounding boxes and show class labels, everything is can be done by OpenCV. Yeah, and then for understanding the output, so the class ID, as we can see, like there are 80 classes in the Coco dataset. So the class ID for example, for the aeroplane, the class ID is 4. And the confidence we can see from our code, like it got 89% confident, like it detected the object correctly, and the box coordinates. That's the x-axis and y-axis. So it can filter by object type. So if we put the input image, like how many number of cars, like the image consists of the number of cars or standing in the queue in the traffic or something. So when we run the YOLO version 8 on that, so it will filter by the car class. So as we can see from the code, like for the car, the the class ID is number 2. So it will detect and it will count the detections. So these kind of problem we can use. And for the weapon kind of thing, like it can be integrated into the web camera, as we saw in the applications of YOLO V8. So we can integrate this YOLO V8 into the web cameras and everything, and it will be useful for surveillance purposes. And then for the weapon detection and for the gun detection and for the people detection, like whoever it can also integrate into the video camera. Like that's the thing like we are going to do in our project. So overall, the YOLO V8 is powerful and it's very fast. As we can see, the pre-process and post-process times are very, very less. It's all in the milliseconds. and it's beginner friendly. So we just need to install the Ultralytics library, and from that we can able to access through all the thing that we can that associated with the YOLO V8. And it's I should say like it's very useful for the real world machine learning application. As I said before in the previous slide, like can be used for surveillance purposes, and for the web camera it can be integrated into that, and then for the medical imaging, the healthcare industry also it can be useful, and we can try it on our own data sets. So these are the resources like we can see on the YOLO V8, and the Coco dataset is here. So when we see the Coco dataset, so these are all the dataset examples. Like these are the things it's already pre-trained into it. So when we get this library into our code, so it will be very easy for us to detect our object automatically. As I printed here, like for the zero for the person, one for the bicycle, and up to 79 it was here. So there are 80 things are there, but whenever something is more than that 80, we should have used that deep learning model. So we have to train the model, and then we have to do that. Like that we can able to do. So this is the final output. As we can see, detected the object, that because there are only two objects in this runway. So as we can see, it can also detect the very small objects. So as we can see from this image, like the car image is very small when compared to this. So it's having that much accuracy that it can also detect the car. So it can be used in various purposes. So as in our project, like, we are gonna do like detect the weapons. So for that we are gonna use this YOLO BV. So this is the overall software that can be useful for our machine learning, and for our future job purposes and everything. Thank you.